This is second video in the MPPT series. So what you saw in the video one was like a project which was like almost 70% complete. So what we will show in this second video is like the initial stages where we did the MPPT measurements, the readings what we took, and the conclusion from those readings, and the design changes what we did after taking the initial readings. So if you see here, like the project is divided into 10 parts, each part is given a weightage of 10%. So as we make progress, we'll move towards the final objective. So the measurements were taken like using two multimeters. One multimeter connected across the solar panel in voltage range, which measured voltage in the range of 5 volts, okay, and 1 milliammeter, which was in series with the load and the solar panel. So 470 ohms resistance were used in parallel, like initial only one resistance, then increased to 2, 3, 8, and 9. Okay. And the current and the voltage readings were recorded. The power reading was calculated using a handheld calculator. And after preparing this table, like the maximum power point was at when there were 6 resistors in parallel. Okay. This is the same readings above, but we have done like what will be the resistance value when we do the parallel combination and the milliampere ratings. Okay. So this table is now put into chart view, and you see like when we go uphill, the power keeps on increasing. It goes to the maximum point and then it drops. Okay. So after doing this readings, we decided to change the load from 470 ohms to 320 ohms to ensure that we have our MPPT at center point, like 4 with 4 in loads in parallel. Okay. So like 80 into 4 gives 320. So that was the basis. So if you see when we connected our load to ULN 2803, we use 320 ohms resistor. Okay. So whatever we did, this resistor parallel combinations, like connecting one resistance in parallel to other and then third and fourth, all these things is done automatically using ULN 2803. The input side of ULN 2803 is driven by digital outputs like D2 onwards, and the ground is common. The output side, we have a resistor network, like each output one is like 320 ohms output to and connected to another 320 ohms likewise. Okay. And this terminal 10, which is common freewheeling diodes, in our case we have kept it open. The reason being, we are using resistive network. There is no inductive load in our case, so there is no need for these freewheeling diodes. Okay. And for the current and voltage measurements, in the manual case, we did is using two multimeters, but in our final project, we are doing it with INA 219. So INA 219 is connected on the high end side. The plus Vin is the voltage from the solar panel. So that will maintain this plus Vin will measure the voltage, and there is a return path, and minus Vin is again connected to the load side. Okay, so whatever is the voltage drop across this zero point 0.1 ohm resistor, that will be used to measure the current, and then voltage and current are multiplied to get the power reading. You have VCC and ground side connections, and for the I2C you have SDA and SCL. Okay, the SDA and SCL are pulled up by 10 k ohm resistor. The A1 and A0 lines are provided for having combinations of I2C address. So if there is only one INA 219 in your project, then there is no need to do anything. The default address will work. But if you have more than one, then you will have to uh, make a combination of these networks, uh, this using these pads. Like by default on the board, it's A0 A1 both pull down, so 0 0. And if you want other addresses, you can have one of the pin pulled up or the other pin pulled up. So basically you have 2 raised to 4 2 raised to 2, basically 4 combinations. So you can have 4 addresses. So in a circuit you can have 4 INA 219 connected with different I2C addresses. So this is the internal circuitry of the INA 219 IC itself, wherein you have power register, current register, and voltage registers. So based on the measurements, this value will go into the register, and this can be fetched using SDA SCL lines. Okay. In our case, we are using the pre-built board from Adafruit. So all we need to do is to connect to VCC ground, I2C SCL SDA, and connect the load and the power supply. In our case, this is solar panel. So for the load side, you have two options like V in plus, V in minus. The smaller male pins, similar to in line with the other pins. So if there is low current, as in our case, because we are dealing with low power, so you can directly use these pins. If you are having heavy currents, then on board there are two holes in the PCB where you can insert a heavy duty connector to connect a load. So basically two options you can choose based on your current. So that's on the load measurement and MPPT readings and the design basis. So next plan after this is like do a DC-DC converter and try other algorithms and do a study of feature enhancements. Thank you.